This is your chemistry teacher bringing you a new topic, that is organic chemistry. Well, organic chemistry means from living materials. All living materials, including our cells, are made up of these compounds. Organic is related to carbon compounds. Carbon can form four covalent bonds, different carbon atoms, or with different other atoms. Well, it has a very specific property that it bonds to itself, forming long chains, rings, and many different structures. So it can form lots and lots of different compounds, variety of compounds. That's why study of carbon compounds is called organic chemistry. Now we'll study organic chemistry in detail, and in this we are going to study introduction to organic chemistry, how we name the compounds, its different properties, different bonds, alkenes, and functional groups, isomerism, and there are so many things which are included in your course, which we are going to study one by one. Let's start off with the study of organic chemistry. It is the study of organic compounds and their properties, and it is named as organic chemistry. Now, organic compounds, these are carbon containing compounds with few exceptions. Carbon forms four covalent bonds with mostly hydrogen and other elements like oxygen, sulfur, etc. Hydrocarbons, organic compounds containing only carbon and hydrogen, are called hydrocarbons. Homologous series, it is a series of a family of organic compounds with the same functional groups and chemical properties. For example, alkanes, alkenes, alcohols, carboxylic acids, etc. Functional group, it is an atom or a group of atoms that gives a molecule its characteristic properties. Organic compounds in the same homologous series have same functional group. Now, I'm giving you the introduction. We are going to study all these one by one. So you don't worry that I'm just giving you the definitions. We are going to study all this in detail. Now, general characteristics of a homologous series. Now, remember, this homologous series is just like a family of different carbon compounds which have same properties. So they have same functional groups, they have similar chemical properties. There is a gradual change in their physical properties as we go down the series from one member to the next. Number 4, each member of the series differ by CH2 unit. Number 5, members of the same homologous series have same general formula. Now we come to functional groups, which I have given you the definition of. Now, functional group, as I have explained, it is the atom or group of atoms which give a molecule its characteristic properties. Just removing one hydrogen and adding a new group, for example, if we add OH, if we add oxygen, if we add nitrogen, if we instead of a single bond we put a double bond, its entire properties changes. Then it comes out to be another series. So number 1 is alkanes. Now it is just hydrocarbon, there is no functional group in it. Remember, you must remember, there are only carbon single carbon bonds or carbon hydrogen bonds, nothing else. Then we have alkenes. If you can see, it has a double bond. Two carbon atoms have a double bond between them. So double bond gives it different properties. It entirely changes the property. So it is a functional group. Then alcohols. Its functional group is hydroxyl. As I have written OH. It again changes. You can see alkane name is changed to alcohol. It has different properties. Then we have carboxylic acid. Its functional group is carboxyl group. C double bond O, OH. And this again changes the properties of the organic of the series. Now we come to naming of the organic compounds. Now it's very important. The first part, which is the prefix, tells us the number of carbon atoms in each molecule. Number two, the second part, which is the suffix, tells us the homologous series the compound belongs to. So, the name of an organic compound is made up of prefix and suffix. Prefix will tell you how many number carbon atoms, and suffix will tell you to which series the carbon belongs. Now, first of all, let's see. Now, I have written this table over here. Number of carbon atoms in one column, then prefix, then suffix, then homologous series. First, we are discussing alkanes. Now, if the alkanes, its suffix is ane, ane, and the prefix is number of carbon atoms. One carbon atom, prefix is meth, suffix ane, so it comes to be methane. Two carbon atoms, eth, ane, ethane. 3. Prop, ane, propane. 4. But, ane, butane. 5. Pent, ane, pentane. And then so on. You can name these compounds. Then we come to second homologous series, where now I'm changing from a single bond to a double bond. So alkenes, they have two carbon atoms joining by double bond. So its first compound is going to start with two carbon atoms because we need at least two carbon atoms. There is no methane, there is no one carbon atom compound. It starts with two. So 2 eth, suffix is ene, so it comes out to be ethene. Carbon 3 prop, ene, propene. Carbon 4 but, ene, butene. Carbon 5 pent, ene, pentene. Now the number of carbon prefix suffix, again there is another series, and this is alcohol homologous series. Its prefix is methan, suffix is all. So the first compound is methanol. Second, carbon 2 ethan, all, ethanol. Carbon 3 propan, all, propanol. Carbon 4 butane, all, butanol. Now we come to the fourth homologous series, that is carboxylic acids. Its suffix is OIC, oic. So carbon 1 methanoic, carbon 2 ethanoic, carbon 3 propanoic, and carbon 4 butanoic. Now I have drawn three structures. First is propene. You can see there is a double bond between carbon atoms 1 and 2. And then there is an alcohol. OH group is attached to the carbon atom, so it becomes ethanol. You can see there are two carbon atoms. And 3, there are number 3 compound, two carbon atoms, so it is ethanoic. And number 1 functional group is double bond, number 2 hydroxyl, number 3 carboxylic acid. Now let's start off with the hydrocarbons series, homologous series, one by one. First of all, I'm going to start off with alkanes. These are saturated hydrocarbons. Now saturated, you must think in terms of, you must have studied saturated solutions, or sometimes you say, I cannot talk anymore, I'm saturated. That is, I cannot listen to one more word, or I cannot talk any more word. So I have no capacity. So the carbon atoms, when they are forming four covalent bonds, they are using all their four valence electrons, and they cannot make any more bond. So these are called saturated hydrocarbons when they are forming 4 single bonds. Now, its definition: a saturated organic molecule is one which contains only single carbon carbon covalent bond. Alkanes are one such type of hydrocarbons. The first member and the simplest is methane, where one carbon is covalently bonded to 4 hydrogen forming a tetrahedron. Carbon has 4 valence electrons, so needs 4 more to complete its octet. I have written its configuration. Molecular formula of methane is CH4. I have drawn the tetrahedron. Red dot shows hydrogen atom, and between in the center of these hydrogen atoms we have a carbon atom with green dot. Tetrahedron is a 3D solid figure with 4 faces. Each bond angle is 106 degrees. You need not remember the bond angle, but you should know that when carbon is forming 4 single bonds, it forms a tetrahedron. Now, what do we understand by alkanes? Alkanes are a homologous series of hydrocarbons that contain only carbon-carbon single covalent bond. Its general formula CnH2n plus 2, where n is the number of carbon atoms. So, when you know this formula, you can make out the formula of any compound, carbon compound with any number. But the most common I have written: number 1, methane, when carbon is 1, you can see with the formula CH4. Carbon number 2, you put the value of N and it comes out to be C2H6. Carbon number 3, again putting the value of N, it comes out to be propane. Carbon 4, butane, C4H10. Carbon 5, C5H12. Now, if you forget sometimes, it's a very common trick you must remember, that is, multiply the number of carbon with 2 and add 2 in it. Now, on the right side, as I have mentioned earlier, that in homologous series, the consecutive member differ by CH2. This is one of the characteristics of homologous series which I have discussed in the beginning. You can see I have written 5 consecutive molecules: methane, ethane, propane, butane, and pentane. And if you see, all differ with each other. The consecutive members differ by CH2. Now let us discuss the structural formula. It is also known as displayed formula. It is the formula which shows how atoms are arranged in a molecule. It shows all the bonds between the atoms in a molecule. I have drawn this table. First column, name, molecular formula, structural formula, displayed or full structure formula. Now you must remember this, that in question what is asked, if they say write full structure formula, even if they say structure formula, you have to show all its bonds. Methane, we are showing all the bonds. Ethane, you can see. And there is one thing which you must remember, that is, each carbon atom should be forming 4 covalent bonds. In propane, CH3, C3H8, CH3, CH2, CH3, you can see the center one is CH2. And if you see the structure formula, you can see that carbon is bonding to 2 hydrogen atoms above and below, and right and left it is bonding with 2 carbon atoms. So altogether it is forming 4 covalent bonds. And same is the case with butane. And one thing, when you are looking at these structures, the carbons which are at the end of the branch have 3 carbon atoms, because one bond carbon is forming with the other carbon bond. So you must remember when you are drawing the structures of these compounds. Now, I have drawn these dot and cross diagrams, which we have studied dot and cross diagrams when we were studying covalent compounds. And it is as these are also covalent compounds, so we should know how to draw their dot and cross diagrams. First, I have drawn methane. You can see 4 hydrogen atoms, carbon atom in the center, and each is sharing, there are 2 pairs shared with each hydrogen atom. So 4 single bonds. Same is with ethane, and then with propane, and between carbon atoms, 2 carbon atoms or 3 carbon atoms, you can see I have drawn crosses with the same color, which means that these 2 electrons are from the same 2 carbon atoms each. It does not involve any hydrogen atom. Alright, now there is another property of alkanes, and that is isomerism. Now, isomerism, it is the tendency of a compound to form different isomers. Isomers are compounds that have the same molecular formula but different structural formula. Let us take the example of butane, C4H10 molecular formula. Now, I have drawn its 2 structures. In first, all carbon atoms are arranged in a straight chain. And in the other one, I have picked one out of the chain, and the chain is now of 3 carbon atoms, and the fourth one I have joined it with the second carbon as a side chain. Now it is called branched chain. So the different similarity is the same molecular formula, and differences: number 1, have different arrangement of atoms as I have drawn their structures. Number 2, different physical properties. Straight chain have high melting point, boiling point, then branched. Now, why I am telling you this thing, that the physical properties, high melting point and boiling point? Now, because of their arrangements. Now, it depends upon the melting point and boiling point actually depend upon the intermolecular attractions. Now, straight chains can be compactly packed like a bag of sticks on each other. So they have more points where they can join with each other, and so they can share more attractions. Whereas the branched one, they cannot be compactly packed. There will be spaces left between, and so there will be less attractions. Now, for isomers, you must have, if you remember your childhood games, you must have been playing with the blocks. And if you have blocks, number of blocks with you, you can keep on making different shapes out of them. Number of blocks will remain the same. If you have 10 blocks, you can arrange those 10 blocks in different shapes. Same is the case with the carbon compounds. As many carbon atoms you will have, that many different structures you can form. But luckily, in O levels, you are going to be asked till carbon 4. So carbon 1, methane, carbon 2, ethane, propane, they have no choices to form different structures. So the different structures, they start with carbon number 4. Now, naming the isomers. Isomers are named according to their structural formula. Number 1, we have to identify the side chain, which has one less hydrogen. So it is named as alkyl, and it is dash CH3, 1 carbon, so methyl from methane, ethyl from ethane, propyl from propane. You can see that it has one less hydrogen. So for that one less hydrogen, I've drawn the dash which actually shows its bond which it is going to form with the other chain. Note, number of isomers increase with the increase of number of carbon atoms, as I have just discussed. Number 2, identify. Now first you have found out the chains which are attached, branch chains. Secondly, identify the number of carbon atom to which alkyl group is attached. Butane, C4H10. First, I have drawn all the carbon atoms in the same single line. So it is N-butane. Then I've taken out one methyl group out of it and it is attached to second carbon in the chain. Now, we are going to number that chain. That is, the methyl group is attached to carbon 2. So it will be 2-methyl. And the longer chain to which methyl is attached is propane. Names come out to be 2 a hyphen. We are going to draw methyl propane. Now this is the way to write down the formula, name of the compound. Then just to give you one more compound, that is pentane. As I have said that as the number of carbon atoms increase, number of isomers also increase. You can arrange them in different ways. So first I have arranged pentane in a straight line. In the second one, I have taken out again one methyl and I have attached it to the second carbon, and the longer chain, straight chain, is butane with 4 carbon atoms. So its name is going to be 2-methyl butane. Now I can make yet another structure, and here I have taken out 2 methyl groups and I have attached these two to the central carbon atom on upper and lower side. So its name is going to be 2, 2, between 2 we have a comma, then a hyphen, dimethyl, as 2-methyl are arranged attached to carbon number 2. So its name is going to be 2, 2 hyphen dimethyl propane, as the straight chain has 3 carbon atoms. 2-methyl are attached to carbon 2, so we write 2, 2 to mention the position. Now again I will tell you that in your O levels it is going to be till carbon 4. Just to give you a little advanced study, that's why I have written pentane over here. So this is all about the isomers, and we are going to study more of this in our coming lectures.